Hi, welcome to today's math lesson on 8.8c. Our lesson target is I will model and solve one variable equations with variables on both sides, and our deal well is given 4 problems. I will model and solve one variable equations with variables on both sides with 100% accuracy. We have a few academic vocabulary words that I want to go over today. So today's lesson is a continuation off of this week's lessons of solving equations with variables on both sides. Today we're going to be introduced to using algebra tiles to help us solve. So algebra tiles can look a little bit differently, but most times they look like a long rectangle and then some squares, and they're usually different colors. One color represents the positive, and then another color represents the negative numbers or negative variables. Throughout the week, we've already learned about algebraic expressions. So each side of the equation has an algebraic expression. An example would be 4x plus 3. And then if the other side were 5x minus 1, that would also be an algebraic expression. Our coefficients are the numbers in front of the variables. So that is 4 and 5 in this case. Our constants are 3 and -1. We're solving for the solution and the value. And to do that, we have to make several zero pairs, first with the variable and then with the constant. And so this is an example of a model and what we're going to be doing today. We're still going to be following the steps of moving the coefficient to one side, moving the constant to the opposite side, and then isolating the variable to find the value or the solution. So in this case, the key says that the green long rectangle represents positive x. So here we have 1, 2, 3, 4, 5. 5 x's, 5x. And then this red box or square represents a negative. So it's going to be the value of -1. So that's why we have 5x minus 1. And then on the other side, we have 2x. And the yellow square or box represents +1. So we have 1, 2, 3. And we have 4 columns of 3, so that's 12, plus another 2, so 14. So then our equation is 5x minus 1 is equal to 2x plus 14. And we're going to get into how we solve the equation using modeling in just a second. So for this model, we have a different key. So as you can see, instead of the green, we have yellow, but the longer rectangular yellow or orange box is representative of +x, and the smaller square box is +1. So in this case, we have x plus 1, 2, 3, 4, 5. So 1x plus 5 is equal to 1, 2, 3, 3x minus 1. So remember that the smaller square boxes are either a value of +1 or -1, and the longer boxes are a value of either +x or -x. So from here, we have to remove 1x tile from both sides. So that's the same thing as subtracting by 1x on both sides. Since we want to make it both sides equal to each other, since they both have x, we're taking out the 1x. And then we're left with 1, 2, 3, 4, 5, 6 single units, because as you can see, we had to add a single unit to this side. So that was the same thing as if we see in our equation, we have 5 is equal to 2x minus 1. To neutralize it, we're going to add a +1 to both sides. So we added a +1 here to make that a zero pair. And then we added a +1 to this side. So that's why now we have 6 is equal to 2x. From there, we have to make two groups, because as you can see, we have 2 x's. So we have to figure out if we made 2 groups that have the same amount, how much would be in one of the groups. And so that was the same thing as 6 divided by 2. And so we figure out that each group, each circle has 3 in there. So that means that x is equal to 3. And so if we model equations, a different equation using algebra tiles, here we have 2x plus 1 is equal to -7. So this is just a two-step equation. It doesn't have variables on both sides, but just to show how algebra tiles work is the simulation. So the green longer rectangular boxes represent the 2x, and then the yellow smaller square box represents 1. On the left side, on the right side, we have -7, as you can see. So to neutralize, to make our first zero pair of the constant, we have to add a -1 to both sides. So I'm going to apply it, and then to apply it, I have to drag it on top. In this case, I can't neutralize it. I just add another -1. So now I have to make equal groupings of the value, which are the constants, so that I see that x is equal to -4. Another example is this simulation right here. We have 5x plus 4 is equal to x plus 12. So we have 5x on this left side plus 4, and then x plus 12. So first we're going to get rid of one of the longer rectangular boxes. And then so that is the same thing as making our first zero pair for our variable. And then we have to make a zero pair for our constants. So I'm going to add 4 zero pairs here. So that was our second zero pair for our constants. Our first one was for our variable. And so now we have 4 groupings, and we have to, or 4 x's, and we have to distribute the 8 to the 4. And we need to know what the value would be for each x. So as you can see, the value is x is equal to 2. So we solved the equation 5x plus 4 is equal to x plus 12 by making sure that first we made the first zero pair with our variable, and then second we made the second zero pair with our constants. So onto this I do, we have to use the algebra tiles to model and solve the following equation. X plus 4 is equal to -x minus 1. So remember that in front of any variable, there is a coefficient of 1. So in this case, our coefficients are 1 and -1. And when we model it, we're using the key where a rectangular green tile represents positive x and a rectangular red tile represents -x. So we have positive x and then the 4 positive square tiles, and then we have 1 negative x and the -4 square tiles. So the first thing that we have to do is make a zero pair with our variable. So to do that, I'm going to add a -x tile to both sides. So that cancels out the x on this side. So that's the same thing as adding x to both sides. So as you can see, now we have 2x. So now we have 2x plus 4 is equal to -4. And so now we have to make our second zero pair with our constants. So we can either add 4 negative values or 4 positive values. So in this case, we chose to add 4 negative values onto the side with the +4. So then that took care of the zero pair of 4 on this side. So now we have 2x is equal to -8. And just like we did in that simulation, we have to figure out if we made 2 groups that have the same amount, what is the value in one group? So the 2 groups, I just drew circles around. So that means that x is equal to -4. And that is the solution to our problem. As you can see, the circles are drawn here. And just to make sure that you guys understand another problem, we can still solve algebra tile equations the same way that we have been solving it the past couple of days. So let's say that we don't have an equation, we just have the algebra tiles, like this model right here. So as you can see, we're going to start off by writing the equation. So we have -3x plus 2, since that's what's represented on the left side, and on the right side we have negative x, or negative 1x, minus, we have 2, 4, 6, 8. So we have minus 8. So we can solve it out algebraically as well. So the first thing that we're going to do is make our first zero pair with our variables. So we can either choose to move the negative 3x to the right side or the negative 1x to the left side. It doesn't matter as long as you continue to fully follow the steps of making the second zero pair and then isolating for the variable. So I'm going to choose to go ahead and move my negative 3x to the right side. So the opposite of negative 3x is positive 3x. So I'm going to add 3x to both sides. So that makes our first zero pair, because negative 3x plus 3x is 0. So then we're left with 2 is equal to, we have negative 1x plus 3x, which is 2x. So now we have 2x minus 8. And now we have to make our second zero pair with our constant. So we have 2 is equal to 2x minus 8. So to do that, we have to move the minus 8 to the other side. So the opposite of subtracting by 8 is adding 8 on both sides. So then 2 plus 8 is 10. And then negative 8 plus 8 was our second zero pair. So we have 10 is equal to 2x. And then our last step is to isolate the variables. So to get the x on one side and the constants on the other. And to do that, we have to divide. Since we have 2 times x, the opposite of multiplying by x is dividing by x on both sides. 10 divided by 2 is 5. 2 divided by 2 is 1. So that leaves us with x is equal to 5. So our solution for this problem is x is equal to 5. Now you'll have to show what you know. Showing what you know in this 4-question DOL in Google Forms. Thank you for following along in today's math lesson, and see you in the next math video. Bye.